In this video, we're going to use logarithmic differentiation to find a derivative. It says find the derivative of y equals cosecant x to the 10x minus 8 power. So how do we use logarithmic differentiation? Well, this is a good example of where it could be advantageous to use it. I'm going to rewrite this just for kicks a different way so that you can see that this is cosecant of x, but it's to the 10x minus 8 power. I like seeing it that way just a little bit better so that you understand that the 10x minus 8 power is on the whole function cosecant x. Now you can see why we would want to use logarithmic differentiation here. Logarithmic differentiation just means take the log of each side and then use log properties to simplify. Once you've simplified, take the derivative. So we're going to do the natural log on each side. So natural log y is equal to natural log of cosecant x 10x to the minus 8. Now, we have taken the log on each side. I can use the log property to bring this exponent to the front. So we have natural log of y is equal to 10x minus 8 in parentheses being multiplied times the natural log of cosecant x. So then we can go through and start taking derivatives here. So we're going to do the derivative with respect to x of natural log y, which is going to equal the derivative of 10x minus 8 times, you can see natural log cosecant x is going to force us to use the product rule here. So we got a multiplication, we're going to use the product rule. So we're going to say u equals 10x minus 8. U prime is the derivative of this, which would be 10. V is natural log of cosecant x. And v prime is going to be 1 over cosecant x times the derivative of cosecant x. So I know the derivative of cosecant x is going to be 1 over cosecant x times the derivative of cosecant x is negative cosecant x cotangent x. So then we can actually multiply that to the top, and that would cancel the cosecants, and we'd be left with a negative cotangent x. Because the cosecant, this is over 1, the cosecants cross cancel. We can now say that this is, if I do the derivative of natural log y, remember the derivative of natural log x is 1 over x. So this would be implicitly 1 over y dy dx. And then if we do the derivative here, we're using the product rule, so we can say 10 times natural log cosecant x, so 10 natural log of cosecant x. And then we're going to have negative cotangent x and this u part, so we're going to say plus 10x minus 8 times negative cotangent x. And then we're going to end up with 1 over y dy dx is equal to 10 natural log cosecant x. And then this would actually give you minus, and I don't know if I probably don't want to really distribute it. So I'm going to just say, actually, you know what, I will. Minus 10x cotangent x plus 8 cotangent x. Multiply the y to the other side, we get dy over dx is going to equal y of 10 natural log cosecant x minus 10x cotangent x plus 8 cotangent x. And then let's plug y back into this equation. So dy dx is going to equal cosecant 10x minus 8 of x times 10 natural log cosecant x minus 10x cotangent x plus 8 cotangent x. I do not see another way to simplify that further, so that should be our derivative using log differentiation.